Hi, my name is Mark Taney, and today I'm going to be teaching you how to multiply by 9. The first thing I'll ask my students is what are the numbers we say when we count by nines? And so they'll start 0, 9, 18, 27, 36, 45, 54, 63, 72, then 81. And then I will write all these multiples on the board in this little multiplication problem with n times n, and n being the missing number. I'll then ask the students, can anyone ask me what the missing numbers are in all of these multiplication problems? And so the children will say, 9 times 4 equals 36. Then they'll come to the board, erase the n, and put a 4 in the n's place. And they'll do that for all the rest of the numbers until they all look eventually like this. The reason why we set up the numbers in this way is to help the children to start thinking algebraically. After all the n's have been replaced by the missing number, I'll ask the students, there is something special. I will then record all of the observations that the students see within all of the answers in the multiplication problems. The first pattern that you can notice is that the ones place in each of the answers get smaller while the numbers in the tens place get bigger. And we can see that if we start at the beginning. 9 times 1 is 9, and 9 is in the ones place. Once we get to 9 times 2, it decreases to 8. It gets smaller. And it gets smaller in 27, 36, 45, 54, 63, 72, and 81. Also, if we look at the tens place, we can see that it slowly increases or gets bigger. So we can see here, 1, 2, 3, 4, 5, 6, 7, and 8. After the students have figured out the first pattern, I'll write it down on the board like this so that the students will be able to copy it and then write an example next to it. Another pattern that we notice is that the tens digit is always one less than the number being multiplied, as we can see here. Here we have 9 times 2, and in the tens place we have 1. Here we have 9 times 3, and in the tens place we have 2. 9 times 4, and then we have a 3. The number is always one less. The third pattern is the sum of the digits is always 9. Don't believe me? Let's try some out. For 9 times 2, we have 18. 1 plus 8 equals 9. Let's try another one. 63. 6 plus 3 equals 9. Our last pattern that we have is that the products are inversed or opposite. And what I mean is, if we look at 9 times 2, we can see the 18. If we go 9 times 9, we see the 81, which are the same digits, only they've been inversed, or flip-flopped, if you will. We sat with 9 times 3, which is 27. 9 times 8, 72. 9 times 4, 36. And 9 times 7, anyone know? 63. If we go to 9 times 5 is 45. 9 times 6, 54. Which are the same digits, only reversed. Now, since we learned all our patterns, let's put them to good use. First problem I'm going to write is 9 times 7. Now, what number is being multiplied by 9? That's right, it's 7. And what is 1 less than 7? What is one number less than 7? That's right, it's 6. Now 6 plus what equals 9? That would be our third pattern, which is saying that the product will always equals 9. So 6 plus 3 equals 9. If you put those numbers together, they are 63. So 9 times 7 equals 63. Let's do one more example. 9 times 6. What number is being multiplied? 6. What is 1 less than 6? 5. 5 plus what equals 9? That's right, 4. 5 plus 4 equals 9. Put those numbers together, and you have 54. 9 times 6 equals 54. You guys getting the hang of it? Great! Okay, let's do one more problem. 9 times 9. Now, what number is being multiplied by 9? That's an easy question. It's 9. And what number is less than 9? 8. And 8 plus what equals 9? That'd be 1. 8 plus 1 equals 9. If you put those numbers together, it equals 81. So 9 times 9 equals 81. Good job, guys. This is some rock star work you guys are doing. Rock star work.